Hello everyone, welcome to the new lecture. So in this lecture we have to discuss about transformer selection part 1. So after the end of this lecture you would be able to understand what is transformer, and I will discuss about the parts of transformer. Then we have to discuss the safety clearance for transformer. So let's start. Now what is transformer? See, it is written, a transformer is defined as a passive electrical device that transfer electrical energy from one circuit to another through the process of electromagnetic induction. So in the context of electrical engineering, a transformer refers to a device used to transfer simple electrical energy between two or more circuits through electromagnetic induction. Okay. I think all of you know about the basic principle of transformer. Transformer generally operate on the principle of electromagnetic induction. A varying current in the primary, you can see here. So a varying current in the primary winding creates a varying magnetic field, inducing a voltage in the secondary winding. Okay, and transformer consists of two coil. You can see here two coil or two winding usually wound around a common magnetic field. Okay, so the primary winding is connected to the input voltage and the secondary winding provide the output voltage. Okay, so transformer core, here you can see this is called as a transformer core. So transformer core are typically made of laminated iron or other magnetic material to enhance the efficiency of energy transfer. Okay, so we have a different types of transformer like power transformer, distribution transformer, instrument transformer. Okay, so each and every transformer has their own advantage. Like if I talk about the power transformer, so it is used for transmitting electrical power over long distances and for voltage regulation. Same way we have a distribution transformer is found in the distribution network to step down voltage for local use. Then we have an instrument transformer used in measuring and protective devices to scale down high voltage and current for safe measurement. Okay, so transformer are highly efficient with a large majority of electrical energy transferred between the input and output without significant loss. Okay, and it is written one point, it is most commonly used to increase or decrease voltage level between circuit. Okay, now the question may be where what is the where we can use this transformer application. So transformer widely used in power distribution system, electronic devices and various electrical appliances. Okay, so understanding the characteristic and application of transformers is crucial in designing and maintaining electrical system, ensuring efficient and safe energy transfer. So this is all about the basic concept of transformer. Now the next which we have to discuss is parts of transformer. So as you know that transformer consists of several essential parts that work together to facilitate the transfer of electrical energy. Here you can see here are the key component. So the three main parts here I am showing you of transformer. First is primary winding of transformer, magnetic core of transformer, and third one is secondary winding of transformer. Okay, so let's discuss one by one. Primary winding of transformer, it is written, this primary winding which produces magnetic flux when it is connected to an electrical source. So remember, the primary winding is the coil of wire connected to the input voltage. Here you can see when an alternating current flows through the primary winding, it generates a varying magnetic field. Okay, so this is the main purpose of primary winding. Next part we have a magnetic core of transformer. So what is this? See, the magnetic flux produced by the primary winding that will pass through this low reluctance part link with secondary winding and create a closed magnetic circuit. So the core is typically made of laminated iron or other magnetic materials. Okay, it provides a path for the magnetic flux generated by the current in the winding, so enhancing the efficiency of electromagnetic induction. So this is the main use. Next one is secondary winding of transformer. So it is written here, the flux produced by primary winding passes through the core, will link with the secondary winding. Okay, so the secondary winding is another coil of wire. You can see here it is given, usually with a different number of turns compared to the primary winding. So the varying magnetic field induces a voltage in the secondary winding. Okay, so these are the parts which we have to know. Okay, so understanding the function and interaction of these components is crucial for the design, operation and maintenance of transformer in various electrical system. That is why I have shown this thing. And here one more point is written, this winding means secondary winding also wound on the same core and give the desired output of the transformer. So these are all are the parts of transformer. Now here you can see I have taken one table standard for, we have some standard size of transformer in market. Okay, so this table we have taken from IEEE or ANSI. Okay, so with the help of this standard, you can see here we have a single phase transformer, their standard size is given. Three phase transformer standard size is given in the table. Okay, IEEE means, I think all of you know, Institute of Electrical and Electronics Engineer. As per this standard, some standard size of transformer is given here, so it is important to know. Now the next table, as per this standard size of transformer is given. Standard size of transformer, power transformer for urban area, power transformer for rural area, then distribution transformer, their standard size is given in kilovolt ampere kVA. Okay, 3, 6, 8, 10, 16s. Okay, as per that we have to do the selection. So before starting the calculation, it is very important to know this all information. Okay, so now the next, in this table you can see the transformer mounting arrangement is given. Based on transformer size, the mounting type is given. Okay, as per standard. So we have to know this thing. That is why I have created this part 1, to understand the theoretical part. After that I will show you how to do the selection. Okay, in next part. So see, if your transformer capacity is up to 25 kVA, so mounting type is what? Mounted directly on pole. You can mount a transformer direct on pole. If it is between 25 to 250 kilovolt ampere kVA capacity, so either on high frame of plinth. So above the plinth only we have to mount it, we have to place the transformer. If it is above than 250 kilovolt kVA, so can be mounted plinth only. And if it is above 100 MVA, so shall be protected by drop out fuse or circuit breaker. Okay, so these are the requirement is given. Then here some requirement of insulating oil is given based on capacity. Requirement of insulating oil is given 1 liter per kVA. Okay, after that next, cable size for transformer as per NPC. Okay, limited it is given. Transformer size, based on transformer size, here you will get the some standard cable sizing. Okay, as per that we have to do the selection. Now see the safety clearance for transformer. So in this table we have taken from NEC, National Electrical Code. So as per National Electrical Code, how much clearance, see, clearance of outdoor liquid insulated transformer and building. So here, if your liquid is less flammable, liquid volume range is given here in the next column. Then fire resistance wall if you are creating, so their detail is given here. Okay, non-combustible wall detail, combustible wall detail, vertical distance how much we want to maintain, so this all detail is given here. So clearance of outdoor liquid insulated transformer and building. So let's say if it is a less flammable liquid, okay, and your transformer liquid volume as per that, if it is less than 380 meter cube. So fire resistance wall, if you have any fire resistance wall, so how much safety distance we have to maintain? 1.5 meter. If it is a non-combustible wall, so if you are trying to place the transformer, so you have to maintain that much of distance and then place it. And if it is a combustible wall, so how much distance it is showing? Sometimes we are placing the transformer in transformer room, so that is why this detail is given. Okay, 7.6 meter you have to maintain the distance, and vertical distance is given here. Okay, so as per a liquid you have to decide everything. Now see the clearance between two outdoor liquid insulated transformers. Suppose if you have placed the transformer in outdoor, so this is also outdoor liquid insulated transformer, or between building how much distance we have to maintain is given. In second table, clearance between two outdoor, suppose if you have selected two transformer, outdoor transformer, so how much distance we have to maintain. If it is a less liquid, if you are using, it is a less flammable and liquid volume is less than 38 meter cube. So see the distance is showing how much between transformer to transformer, 1.5 meter. Okay, if it is greater than 38 meter cube, so we have a different requirement. As per that we have to select. Now the next is given dry type transformer indoor installation as per NES. Okay, their detail is given in this table. And transformer clearance for building as per IEEE standard, Institute of Electrical and Electronics Engineer, based on transformer capacity. See the distance from building, how much you have to maintain. Minimum distance is given. If your transformer capacity is up to 75 kVA, so minimum 3 meter from you have to maintain the distance from building. Okay, as per that you have to do this selection. So now the topics which we have covered in this session is what? Transformer selection part 1. Same way I will upload the next part. In that part I will show you the calculation, okay, how we can select the transformer for our building. So here, if you are, my video is important for you, so please do not forget to like, subscribe my channel and share it to your friend. And our Udemy course is also available in description. Just go through it, you will get more detail about it. Okay, so I hope all of you enjoy this session. See you in next one.